Hello guys, this is Paul McWhorter and I am here with Arduino lesson number 16, and hopefully you've been through the earlier lessons with us. We're learning a little bit more every lesson, a little bit more about programming, a little bit more about circuits, a little bit more about programming, a little bit more about components, and at this point you've got a really good idea for the basics that you need to do some pretty sophisticated programming. And so we're going to start looking at additional components. We're going to start looking a little bit more on the circuit side of things. And so what we're going to do today is we're going to start looking at making things move, where we can get things moving with the Arduino. And so the component that we're going to be looking at is called a servo. And the way a servo works is it moves. The position of this little horn can be controlled by the commands that we send to this from the Arduino. The important thing to understand about a servo is that you need to understand that it is not a motor. You can't just turn it on and have it go in a circle. It typically has a limited range of motion, and that limited range of motion is usually from about 0 degrees to 180 degrees nominally. That's kind of what they say they are. Most of them don't actually go through that full range, and so we'll talk a little bit more about that in a minute. But this opens up all types of exciting new possibilities on your project, to where you could get input from the user and you could use that to control where this thing went to, or you could have a sensor and have the sensor control what this thing did. So you could have it, you could imagine something where you could have like a little window, and if it got hot, then this thing could open the little window or close it. And again, there's a lot bigger ones that you could use, but we're playing around with this small one. This small one is the one that comes in the SparkFun Inventor Kit, and for this one there are basically it's a small one, and it can be driven directly from the Arduino. There are 3 lines on most servos. There is, on this one, the color code is, there's a black, there is a red, and there is a white. And what those are is, the red is where you put the power to the servo. For this one it wants 5 volts. The black is for ground, and the white is the control line of where you send the commands to make the thing actually move. Now this is really important. These small ones, like this one that comes in the SparkFun kit, you can power those directly from the Arduino. The Arduino has enough power to power a small one like this. But the thing is that these servos draw a lot more current and a lot more power than what you think they would. It doesn't look like it's doing that much, just spinning back and forth, but it turns out these things really draw a lot of current. You want to make sure that you're not trying to drive one from the Arduino power supply that is trying to draw more current than what the Arduino can provide. And some of them that are just a little bit bigger than this are too much to try to put on the Arduino. Several things happen. One is you can damage the Arduino, you can burn out your Arduino. Another thing is that maybe it doesn't burn out the Arduino, but it doesn't run very smoothly, and you get a bunch of glitchy type of behavior out of it. So you want to make sure that you have enough power for the servo that you're using. In some cases, what you can do is you can still use the control line hooked up to the Arduino, but on the power line you could power it from something that could provide more current, like an external voltage supply. You could power it, making sure you're always using the right voltage for the particular servo that you're running. So sometimes the Arduino can control larger servos, but it just needs to be doing it through the control line and not through the not trying to draw the power from the Arduino. One thing I always remind you, anytime you start getting more power supplies or getting your circuits more complicated, make sure all of your grounds are hooked together. The ground from the Arduino needs to be hooked to the ground from the circuit that needs to be hooked to the ground from the power supply. So when you're doing these things, usually when I'm looking at students' work, one of the common problems that I see when they're having problems is they don't have all their grounds hooked together. So make sure that you get your grounds, your circuit really grounded well. So this is a pretty exciting little component that we can start working with. Another kind of warning I got to give you is that, man, so much of the stuff that you do with Arduinos and electronics and engineering is just like everything works perfectly. It's just all these components are like cheap and they work great. The servos, not so much. The servos seem like I have more problem with servos than just about anything else. I'll get one and it doesn't work, or I get one and it's jittery, or I get one and it doesn't work the way it's supposed to. And so just to understand, there's a lot of kind of not so great servos out there, and particularly these little cheap ones. A lot of times you'll get one that doesn't work very well. And one of the things to be aware of is when you buy one of these little guys, it says that it can go from 0 to 180. So if I hooked a pin up to this, this would be like, it would, you could position it supposedly from 0 to 180, okay, from 0 to 180. But what I found is that they rarely ever go over the full range that they advertise. And one of the things that's a problem is that if you try to overdrive it, if you try to drive it past the point that it wants to go, it starts jittering and it starts drawing a whole lot of current. That could damage your Arduino, or it could damage your servo. And so what you got to do is, usually when I get a servo, the first thing I do is I write a little program just to see for that servo how far it wants to go. And like if you look at this little guy here that I have, you can see that he's not going over the full 180-degree range, and that's because I'm not driving him to go over the full 180-degree range, because when I was playing with it, I saw that he didn't want to go all the way to 0, and so I didn't try to drive him all the way to 0. So when you get a servo, it's good to play around with it and see its natural range of motion that you can get without it starting to jitter. The other thing is that don't try to turn this with your hand. That can be very bad on a servo. Don't force drive it. Only drive it electrically. Don't come in and start trying to spin it by hand, because that can cause a problem with some of the servos. And so, servo is one of the trickier little components to work with. If you're having trouble with one, sometimes what you need to do is you just need to kind of toss it and get another one, because a lot of times some of these things just don't work very well. Okay, so what are we going to do? We're going to start playing with this thing. And I guess a couple of things. What the objective of this lesson is that we want a circuit where we have a potentiometer, and then we want the Arduino to read the voltage off of the potentiometer as a voltage divider. I think it was lesson 10 that we went through how to use the potentiometer as a voltage divider and how to make Arduino reads from it. So what we're going to be doing is we're going to be reading the position of the potentiometer by reading the analog voltage off of the center pin, and then as you spin this thing around, that number that you read, the voltage will go from 0 to 5 volts. The number that you read will be between 0 and 1023, with 1023 representing 5 volts and 0 representing 0 volts. And so you'll be reading a number on an analog pin between 0 and 1023. Then what I want you to do is to take that number and have that then control where the servo is pointing. So basically, I want the servo to track the potentiometer. So if you have the potentiometer all the way to the left, the servo's all the way over. If you put the potentiometer, the servo smoothly tracks where you set the potentiometer. So that's the assignment. What the good news is that you pretty much already know how to do the servo, or if you don't, go back and look at, I think it was lesson 10, and then you'll see how to use the potentiometer. Go back and look at at Arduino lesson number 10 to see how to use the potentiometer. And what we're going to learn today is we're going to learn how to use this servo, and so we're going to probably just jump right in here. I guess I need to go back and for the code I'm using, for the code that I'm going to be using here, we use this schematic. This is on my website, toptechboy.com, and this is, again, lesson 16. And this is the schematic of how I've hooked up the potentiometer. The center leg going to pin A0, the bottom leg going to the power rail here, the power rail going to 5 volts, and then this leg going to ground, and then ground going to ground. So again, all my grounds hooked up, and then reading off of this center pin. And so that's how you do the the potentiometer side of things. I couldn't draw the servo over here, so I'll just kind of have to tell you how I did the servo. On the servo, I am hooking the control line of the servo. For this one, it's the white line. I am hooking that to pin 9. Okay, the servo is hooked to pin 9. to be used as the control line. The thing to understand about that, though, is that you can use any of these digital pins you want as long as it's one with a squiggly line, because you're going to be doing one of these analog writes to it. And so because we're doing analog writes, you need to make sure it's a pin you can analog write to, and those are the ones with the squiggly lines. 9 is a good choice, and that is the one that I'm going to use. Okay, so I've got on this servo, I've got the control line, which is the white line, hooked up to pin 9. I've got the 5 volts to 5 volts. I go through a rail here that I established from the Arduino, and then ground to ground. And with that, then you're going to be nominally set up to start working with this thing. So let's see if we can go in, and let's see if we can start writing some code. Let me get me a new Arduino integrated development environment up here so that we can get going. Okay. The good thing is you start getting into some of these components like servos and getting into some of these more sophisticated devices. There's what's called libraries, and libraries are code that someone else has written. Either the people that develop the Arduino or the people that develop the servo or component product, whatever it may be. They write libraries, and then when you use those libraries, it makes it a lot simpler and more intuitive to work with the component. It just makes it really easy to send commands to it, so you're not having to work down there at a very, very low level. You're able to work up where it's a little bit easier. But to use those libraries, you have to begin by loading the library. And I don't think we've done this before. The way you load the library is you got to know the name of the library, and you start to load a library by the pound sign, and you say include. That is telling Arduino to load a library. And then you have to tell it the name of the library. This is servo.h, and then close it. And then what are we doing? We are loading the servo library. Okay. Now another way you can do it, let me just let me take this much of it off, and you believe it or not, on these loads I messed up here. You don't put a semicolon. It just ends like that. So on your library includes, one of the few places, no semicolon. Okay. There's another way you can load it. A lot of times what you can just do is you can come in here, and if you look under Tools and you can look under Sketch, under Sketch, you can say Import Library, and you can see the servo library is right there, and I can just load my servo library there, include servo.h, which I said, and let me put my comment back up there. Okay, loading the servo library. All right, now what we need to do is we need to set up some variables. Well, one thing that we're going to have to do is we're going to have to write to this thing. We're going to have to make writes telling it where to go to, so we need a variable to hold that number that we're going to write. And what we're going to write is we're going to write position. So I'm going to put a variable called position, and I'm going to set it initially equal to 0. Okay. Declare and initialize the POS variable. Okay, so that gets us a variable to use. The other thing is we need to keep track of our pins. And remember, we've got the servo hooked up, so we're going to say servo pin. And where did we hook that? In my circuit, we hooked it up to 9, so we need to tell it, tell Arduino that that servo is hooked to pin 9. Okay. Then I'm going to have a potentiometer, or not quite yet. What I'm also going to have is I'm going to basically, every time you write the servo, you need to pause just a little bit of time to give it time to move. And so I'm going to have a servo delay so that I can put this in just to slow it up a little bit so you're not trying to overdrive it. Okay, 25. And then, okay, and then that's probably going to be my variables. Now let me tell you what we're trying to do in this. Remember how I told you that on these servos you don't want to overdrive them, right? That they say they go from 0 to 180, but typically they don't really go from 0 to 180. And so if this one only wants to go to 25, you shouldn't try to drive it to 0, because then it starts shaking and it starts drawing a lot of current. It can burn the servo out, or it can damage your Arduino. So what you want to do is, for the servo you're using, you want to kind of find what the natural range is. And so what I want to do with this first little program is I just want to go out to the user and I want to ask the user over the serial port, what position would you like to set it to? And then I want to move to that position. And what I can do is I can try to go to 0, and if it starts shaking, ooh, I shouldn't go to 0. So I'll come back and I'll say, well, maybe I can go to 10, or maybe I can go to 20, and kind of find that range of how small of an angle it can go to without a problem. And then at the same time, I want to find at the high end, will it go to all the way to 180, or does it only want to go to 175? So I sort of need the low end and the high end that this thing naturally is happy running at. And so I've got to write a program that'll go out and ask the user for a number. You type the number in, and then it goes to that value, and then you can just sit and just sort of observe it and see what range that it seems to be happy at going in. And so that's why I need to write this program. So position is going to be the value that you get from the user that you're going to set. You're going to try to set it to that position. Servo pin is 9. That's where I am getting that's where I'm sending the command to the servo of what position to go to. And then servo delay is how long I'm going to wait after I write it. I think that's pretty good on my variables. Now this is the new part. Okay, when I put this servo that I'm going to be working with a library, I need to now create an object for Arduino to work with. And that object is going to be a servo object. But I got to name the object. I got to tell it, what do I want my servo to be called? And I create that object when it's a servo object with this library with the command servo, and you do this up at the top of the program like where you're declaring your variable servo. And since this is a pointer, I could call it my servo, or I could call it little servo, but I think because I'm pointing, I'm going to call it my pointer. Okay, so what this tells Arduino is create a servo object called my pointer. You could call it whatever you wanted to, but you tell Arduino it's a servo with this servo with the uppercase S. Okay, so now I've created the servo. Okay, I've created the object called servo to work with in Arduino. All right, now let's come down to the setup, and what are we going to need to do? Well, we're going to be working over the serial monitor, so we need to do a serial.begin. Okay, and we'll work at 9600 just because that seems to work pretty well. And then what we need to do is we have to tell the Arduino, we've told the Arduino, hey, I've got a servo, it's called my pointer. Now we have to tell it, how do you communicate to my pointer? Where is my pointer connected? And the way you do that is you tell it that my pointer dot attach. You're telling it that this object, that's a servo called my pointer is attached to the Arduino at pin 9, right? No, it is attached to pin 9, but I don't put pin 9 in here. That's why I put this up here, servo pin. Okay, it's attached. My pointer, which is a servo that I created here, is attached to the server at servo pin, and servo pin is 9. Okay, so now Arduino knows that I have this object called this object that's a servo that we've named my pointer. Where is it attached? It's attached to the circuit at servo pin, which is pin 9. Okay, so hopefully that makes sense. I think that's all we need to do right now in our void setup. Now in our void loop, what are we going to do? We're going to go ask the user for input, and then we're going to put the servo at the angle that the user indicated. So to get input from the user over the serial port, what do? 3 things. Number 1, we prompt the user for input. After we prompt him for input, we wait for him to put it in. And then after he puts it in, we read it. So the first thing we do is we are going to prompt him. And we will do that with a serial.println. It's all on one line, so I'll put a ln. What, where would you like to position the servo? Okay, so what are we doing? Prompt user for input. Okay. Now, after we prompted him for input, what do? We wait for it. How do we wait? We wait in a while loop where the condition is serial.available equal 0. So what's that saying? If there's nothing on the serial port, that means he hasn't put the data yet. While we're waiting for data, we sit here in this loop between here and here, and we do absolutely nothing. It just sits there. Is there anything on the serial port? No. Is there anything on the serial port? No. Is there anything on the serial port? No. As long as there is nothing on the serial port, it just sits in loops. As soon as he enters the number, then there is something on the serial port. Serial available is not 0, and it drops out to the next step. So this just hangs until the person puts the data in. Then what do we want to do? Well, we want to get that. And where do we read that number into? Well, that's the position number. That's going to tell us where to go, and we've already set that up. So we're going to say position is equal to, how do I read an int off of the serial port? That was parse. Serial.parse int. Like that. So it goes out and it gets that number off the serial port and it puts it into the variable POS. Okay, so that should do that. So now we know what the position is. So how do we get the servo to go to that? Well, we talk to the servo. What's our servo name? My pointer. So we go my pointer. Why? Because that's what I named it. Okay, my pointer. That's what I named it. Dot. What do we do to it? Write. And what do we write? We write our position. Okay, so this number position we're going to write to the servo called my pointer, and that's what it's going to do. Okay, let's get back up here and put some comments in. Read user input. Write POS to servo. All right, I think this is going to work. Okay, look at this. This is happy. So let's go to our serial monitor, and it's asked me, where would you like to put the servo? Well, let's just say 90 degrees, kind of in the middle. Okay, we were probably already about there. Let's say 45 degrees. Okay, there it goes. Let's say 130 degrees. There it goes. Okay, what was the purpose of this program? It was to find that range of motion that this is comfortable going without it starting to shake and vibrate. So let's just say if I go to 0, okay, now what I can do is I can feel this thing is really shaking and straining, even though that you can't see it, and I can see that's not good. So I'm going to go to like 30 degrees to get it off of that. You wouldn't want to leave it there. Okay, so now it's come up and it's gone away from that. Let's see if I could go down to 5 degrees. Okay, it's still straining at 5. That's too far. Let's go back to 30. Okay, let me see if I can go to 10. Still not happy. Okay, at 15 it seems pretty happy. So let's see if I go to 25, it goes there. If I go back to 15, it goes there. So it seems, let's see if I can go to 20. You see, it seems like down in that region, 15 is about the low end of where you can go with it still being happy. And so make note that the low end is 15 degrees. So I've written that down. Now let's look at the high end. If I go to 180, okay, it is straining. So let's go to 160. Okay, 175. Okay, it's still straining. 160. Okay, let me try going to 170. You know, it seems pretty happy at 170, and then if I go to 165, you can see it moves, and if I go to 170, it moves. And so you see 160, 170, it's happy, it's still in that range. And so I'm going to say for this particular sensor that, for this particular servo, well, the one down here, that particular servo is doing pretty good from 15 to 170. So basically I can go from 15 degrees, which is over here, to 170. Now the thing that kind of irks me, you pay for 0 to 180 and you get 15 to 170. It's like you're kind of getting cheated out of 25 degrees. But I guess that's what happens when you buy a $3 servo, that if you spend $30 on a servo, you'll probably get one that works a little bit better than this. But now we sort of see the range of motion that this servo is happy working in. So let's play around with our program a little bit and let's kind of take it up to the next level. I sort of know 15 to 170. So let's see if I can just kind of sweep back and forth between those two. So how would I do that? How would I smoothly sweep over a range? Well, I could do that with a for loop. And I could say for, and what would I want to loop on? Well, I'm wanting to loop on what? The position. Okay, so I can go from position is equal to, where do I want to start? 0? No, because 0 is too far. I want to start where? I want to start at 15. So for position is equal to 15. And then to position, keep looping as long as position is less than or equal to what? 170 was what seemed to work pretty well. Okay, and then what we would say is position is equal to position plus 1. Okay, and this is a for loop, so we start a clause, and then we come down here and we end the clause, and everything in between here it will do, starting the first time through position, POS is going to be 15, and then 16, 17, 18, 19. It's going to keep looping as long as POS is less than or equal to 170. Once it is not equal to less than or equal to 170, which means when it gets to 171, it'll drop out and then move on with the rest of the code. And then we tell it POS is POS plus 1. Okay, so what do we do inside of this loop? Well, we will want to do a my pointer dot write, and what do we want to write? Position. Send servo to POS. Okay, and we got to be good and remember our semicolons. And then after we write it, it's always good to delay. So we're going to delay a little bit so that we're not trying to drive it too fast. And I'm going to say 25. I'm saying the 25 milliseconds is good, so we set that up as servo delay. And the cool thing about this is that if you have lots of delays in there and you want to tweak them, you just do it one place up here, and then everywhere you've used servo delay, it'll change it. So let's just say this is going to pause a moment. Okay, this should go from 15 to 170. It should be happy in there. But once we go there, we want to sweep back, so it's going back and forth. So we need a second loop. That first loop is going to take it all the way over to here, and now we need to take it back. Well, I like to copy and paste, and so I'll just copy and paste this and then kind of fix the things that needed to be fixed. And so here is the second loop, but here instead of going from 15 to 170, where do we want to go? That's right, we want to go backwards. We want to go from 170 to 15. But you got to think, you want to loop as long as position is less than no. In this case, you're going backwards. It would be greater than or equal to 15. So you would want to go 170, 69, 68. You would go as long as you're more than 15. And because you're coming backwards, that should not be post. That should be pos. Position. Position is position plus 1. Position is position plus 1. But we don't want position to go plus 1. We want it to go from 170 down to 15. So position should be what? Position should be position equal position minus 1. So on this one, it's counting backwards. So it counts forward to 170 and then backwards from 170. And then the rest of this should be right. I think this is going to work. Look at that. This is going to work. Okay, and here it goes. Okay, it's sweeping up to 170 and then sweeping smoothly down from 170. And looking at it like this, you can see that you're really getting cheated out. You're not getting, you're not getting the 180 degrees out of this thing that you'd hope to. That's that's not such a hot deal. The rather limited range of these cheap guys, but nonetheless, that is really something that I think is pretty cool. And you can imagine that there's all types of things you could do. What's a way that we could make it run a little faster maybe? Well, you could say take out the delay, but you really need a delay in there, right? You really need that delay in there because you don't want to overdrive it. What could we do? What if we said position is position plus 2, and then let's let it go slow on the way back. So it's going to go faster this way and slower that way. Let's see if that happens. Yeah, look at it go. And then nice and slow, smooth back, and then faster coming this way. And slower going back. Let's say if we can even exaggerate that a little bit more. Yeah, you see real fast in one direction, slower in the other, because we're jumping 5 steps at a time, going in the forward direction, 5 steps at a time. So you see, you can play around with this, and there's a lot of different parameters that you can play with to kind of make it do different things and sort of do what you would like it to do. Okay, but what was the objective that we wanted here? We wanted this thing. We just kind of been playing around with it to see what its range of motion was. What we really want it to do is we want it to track the position of the potentiometer. And I'm going to download that first program so this thing will stop spinning back and forth. Okay, stop it there for a second. All right, so what do we want this thing to actually do? We want it to not be set by a position from the serial monitor. We want its position to be set by where this potentiometer is. And remember, we're reading this potentiometer, the center leg of the voltage divider over here at pin A0. When you read a voltage from the potentiometer, you are going to be reading for the circuit the way we have it set up here, hooked up to 5 volts. You're going to be reading a voltage from 0 to 5 volts. Okay, but what number are you going to see at the analog input pin? 0 to 5 volts is going to correspond to a number between 0 and 1083. Okay, so the number we're going to be working with is 0 to 1083, and then that needs to map to, now you got to think about this, you don't want a read of 0 on the potentiometer to take you to 0, because that would be overdriving the potentiometer. And if somebody came in and didn't know all this stuff you and I know about not overdriving potentiometers, and they turned it all the way to the left, then it would put it in that position to where it would be shaking, and the user, without knowing any better, could burn your stuff out. So you got to make sure that he cannot set this at lower than what? We determined the low end was 15. So when I read a value of 0 from the potentiometer, what value should I write to the servo? Not 0, I should write 15. Okay? Think about that. And similarly, on the high end, when I'm all the way to the other end and the potentiometer is reading 1083, I don't want that to write to 180, I want that to write to what? 170. Okay. Guys, this is not something you can just wing. And if there's nothing else you learn in these classes, I hope that you learn how to apply the math that you've learned in math class to a problem like this. What is our independent variable? What is our variable on the horizontal axis? It's 0 to 1083. It's what's coming off this potentiometer. I can set this to 0, I can set it to 1083. This is the independent variable. It's the horizontal axis. What is the axis that I'm going to? The dependent variable is this. It's this. It's the vertical axis. The vertical axis needs to go from where? 15 to 170, when the horizontal axis goes from 0 to 1083. So this is going to be some math. So let's look at this. I want you to be able to read this. So let me see if I can. Okay. So controlling a servo with Arduino, and I wish I was one of these guys that had that real neat precision engineering looking handwriting, but I am not one of those guys, and so you will have to live with my poor handwriting. I do it as neat as I can. Controlling the servo with Arduino, number one, what you need to do is figure out the minimum and maximum range of travel for your Arduino servo For mine, it was 15 to 170. Don't come in and use 15 to 170. If I plug this servo in, it's going to be different than that one. And so for the particular servo that you're using, you need to find out what that safe range is. For this one, plugged in, it's 15 to 170. What you need to do now is map that range onto the values you will get from the potentiometer. So let's do our math here. Okay, let's do our math. Okay, so the independent variable is what I control. That is the position on the potentiometer. That is going to create a number between what and what? Between 0 and 1023. Okay, so that's this horizontal axis, the potentiometer reading. Pot reading is going to be between 0 to 1023. Over that range, what values do I want to apply to the servo? Well, at the low end, I want to apply 15, and at the high end, I want to apply 170. So when the potentiometer reads 0, the x value, I want the position or the servo to go to 15. When the potentiometer reads 1023, I want to put the servo at 170. So we have 2 points and we have a line. But what we need is we need the equation of that line so that for any reading on the potentiometer, I can calculate the POS value, the position value to put on the servo. So how does that work? Well, we find the slope of the line. What is the slope? Let's get back to math class. You've been doing this for years. Just, you guys, it's like you learn all this stuff in math, and as soon as you walk out of math, it's like you forgot it. You walk back into math, you could do these all day long. Just boom, 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 boom. I see you. I see you working these, but you walk out of math class and you come into engineering class and it's like you never saw a line in your life, okay? So know how to take those math skills that you're learning in math class and bring them into the real world. How do you find the slope of the line? M is y2 minus y1 over x2 minus x1. What is our y value? It's 170 and 15. So y2 minus y1 is 170 minus 15. x2 minus x1 is 1023 minus 0. 170 minus 15 is 155. 1023 minus 0 is 1023. I hope you understand this. I hope you get this in your head, okay? Then how do we've got the slope of the line. How do we get the equation of the line? Well, what do we have? We have the slope and we have a point. So let's use the point slope form of the line. What is the point slope form of the line? Y minus y1 is m onto x minus x1. I could choose for my point either this one or this one. This one has a 0 in it and a smaller number, so I think that one will be easier, so I will use that one. The other one would work. I like to try to find the easy way. So y minus y1 is y minus 15 is equal to m, which we already said was 155 over 1023 onto x minus x1. And what is x1? x1 is 0. So y minus 15 is equal to 155 over 1023 x minus 0. I can move the 15 to the other side, and I have y is equal to 155 over 1023 x plus 15. Now let's turn this into the variables that we're using. I always do it in x and y because you remember back from math class, but our y was POS, so our y becomes POS, and our x was pot reading. So POS is equal to 155 over 1023 times pot reading plus 15. Okay, this is the equation that we use to calculate the position that we're going to write to the servo from the number that we read off of the Arduino. Okay, off of the potentiometer on the Arduino. So let's see if we can make this little guy work, and I'll see if I can kind of leave this equation on here so that we can continue to see our nice math work as we continue on with this. Okay. You know what, I can probably back this off a little bit now so you can see the whole thing. Okay. All right, so hopefully you have your circuit put together and you can just code alongside of me. So let's see here. Let me get these things set up. Okay, this is going to be kind of amazingly simple in our loop. What do we want to do? We want to go out and read that value off of the potentiometer. How do we do that? We say our variable. What did we set up? We better set up a variable up here, and we're going to call that variable int, and we're going to call it pot reading. We're not going to give it an initial value. Declare variable for potentiometer reading. Okay, and so pot reading, how do I read it? Well, we do an analog read, uppercase R. We got to tell it where we're going to read. Where do we read? We read not servo pin, but we read pot pin, which we have not set up yet. So we need a pot pin. When we set up these variables, we did not have a potentiometer in the circuit yet. Pot pin for me is A0. So integer pot pin is equal to A0, not O, uppercase A, 0. It won't work the other way. Okay. Connect potentiometer to pin A0. Okay. So now we do our analog read where pot pin, which it knows is A0. Okay. What we're doing is reading potentiometer. All right. So we have our pot reading. Now we've got to calculate our position. How do we figure out the position we want to go to based on this? Well, we just did the math. Position is equal to what? Well, it's equal to 155 divided by 1023. And guys, when I do division, I always do point. Because if you don't put a decimal in there and you do integer division, strange things can happen, and they are usually not good. So I always put 155 point divided by 1023 point. That tells it to give me a floating point number in here. Okay, times what? Pot reading that I just took, okay, plus 15, because that is what the math said. Now we know position. What do? We write it. So I say my pointer, that's the name of my servo, is equal to, or my pointer dot write, and we write that position. Okay, so this is calculate position, and this is write position to servo. Okay. One thing to understand is your equation is not going to be the same as this. You need to do this for your own part, and you're probably not going to be at 15 and 170, so you need to go through the math for your particular part. Okay. And when I come around to grade this, for those of you in my class, I'm going to be looking and making sure that you didn't just lift my equation, but that it really is right for your servo. Okay. I'm going to be checking you and checking you twice on that. Okay. And if you're doing this on your own, be good, because you're not cheating anybody but yourself if you don't really go in and know how to do this. Okay, I think this is going to work. Let's take a look at it. Okay, so now as I twist this knob, it should gently go from 15 all the way to 170. So if I'm all the way to the left, it's over there at the start, and look at this. I can just very smoothly. Let's go back a little. Let's come back a little. You see, I can put that wherever I want just by turning this all the way to 170. Go back a little bit. Come back. That is just super cool. And I like the little arrow that's on there because you can kind of see, you can kind of see where it is a little better. You can see the thing moving as I turn this. Well, I just think that this is just super, super, super cool. Okay, I really like playing with this thing. Okay. But one of the things I briefly want to kind of touch base with you on is that what I want you to do now is I want you to go out and kind of create something with this. I want you to just hook up some simple little thing. Maybe you make a paper box that you open the window on, or something that you hook this to. But I want you to do something. And for those of you in my classroom, we've got the 3D printer. You can print something up on the 3D printer that does something. You can make something, but what I want you to do is go out and be a little bit creative in what you create with what you've learned with using a servo and a potentiometer, or hook the servo, drive it from the serial port, or drive it from something else. What if you remember the color sensor? Put the color sensor on there, and depending on the color of the card, the color of the card that the sensor sees, make the servo do something interesting. So the problem is that so many times in engineering, what I see is that we get so focused on the nuts and the bolts and the code that we don't really think for why. For why do we learn this stuff? Okay. The reason we learn it is we want to do cool stuff. So I want us to spend more time thinking about the cool things that we can make and not just sitting here making things move for no reason. And one of the things that I find interesting, those of you that are in my class know that for most of these projects we have a contest, and whoever does the best wins the contest, wins a stereo or some cool piece of electronic gear. And the kind of thing that I see is that sometimes the kids that are the best coders and have their program and their circuit all up and running in 5 minutes, their project is kind of dull and boring. And sometimes it's that kid that's maybe a little bit slower at getting his code working, a little bit slower, kind of like maybe sometimes the last one to finally find his mistake and get the code working. But it's that kid that just blows me away with the creativity of the project. And I'll tell you guys, I was an engineer for 30 years, an electrical engineer, and the successful electrical engineer is not the guy necessarily that can code the best, but the guy that can make things appealing and user-friendly and attractive to a user, something that draws a user in, they want to sit and play with it. And so I just really want you to not lose that creative aspect of things. And so I just encourage you to think creatively in how you can use this servo as part of a project that would do something neat and cool. And so we'll have 3 or 4 days to work on this, probably the rest of the week, and then I will come around and we will be looking at just how creative you can create a project based on loosely something associated with the servo and the potentiometer. Again, if you're not using this servo, make sure that you aren't trying to drive one from the Arduino unless you're sure the Arduino can give you the juice you need to do that. Okay, Paul McWhorter, this was lesson number 16, I believe. Hope you will tune in shortly for lesson number 17. We are signing out.